unmuted.
Hello, I will start speaking. My name is Louise Horne, and I work as technical sales for market pulp at BILLERUDKORSNÄS, and I'm going to talk to you about high quality NBSK and especially our market pulps that we have and their special qualities. So my agenda is that I'm going to start with a brief introduction about myself and what I do. I'm then going to go on and talk about BILLERUDKORSNÄS as a company and present that to you and how we work. I'm then going to move on into more fiber and pulp related questions, so how the fiber influences the product properties, and also present our 3 market pulps to you, and then have a short summary and room for questions. So about myself, as I said, my name is Louise. I am an engineer and also Master of Science in Biotechnology from the Royal Institute of Technology, or KTH, here in Stockholm. I am working as technical sales for pulp, as I mentioned, and started working for what was then called Billerud 2 years ago in 2011. And I worked at our mill in Karlsborg in the north of Sweden for 2 years, and I just moved to Stockholm to our head office a month ago, and now working as technical sales. And if you come up with any questions after the presentation or want to contact me in any way, you can do that by emailing me afterwards or adding me on LinkedIn if you want to. So starting with the BILLERUDKORSNÄS, the company as such was established about a year ago in November in 2012. But before that we had 2 companies called Billerud and Korsnäs. And a year ago Billerud bought, you could say, Korsnäs, or we merged into one big company. And we are a leading provider of renewable packaging material. And together with our partners, we want to create smarter packaging solutions that will increase profits, excite millions of consumers, and contribute to a sustainable future for generations to come. So the market pulp that we have, you could say that it's in line with the latest environmental demands in Sweden. We are continuously working on improving our processes, both when it comes to yield but also environmental issues. And our mills are certified, among others, with the FSC certification, and we can offer FSC controlled wood or FSC certified or PEFC certified pulp to our customers. So if we look more on the facts and figures of the company, we see that the right to packaging is a key in an expanding global market, which is expected to grow, as you probably know, with over 3% per year. And since prosperity is increasing around the world, our ambition is to grow along with it. So we want to meet the demand in our existing markets, for example, Europe, and we also want to meet the demand in the growth markets, as the Asia Pacific and the South American regions. So we have a combined net sales in 2012 of 20 billion Swedish kronor, which is around 2.2 billion euros. And we have, since a year ago then, 4,400 employees in 13 countries. So in the countries where we don't have production units, we have sales offices. We have 8 production units producing packaging paper, consumer board, container board, and also market pulp. And that is Beetham in England. We have Frövi in Sweden, Gruvön mill that produces market pulp. We have Gävle, also in Sweden, Karlsborg, which is also producing market pulp. Pietarsaari in Finland, SKÄRBLACKA in Sweden, also market pulp, and Tervasaari in Finland. So all of these Swedish mills produce both pulp and paper, but only 3 of them produce market pulp. So we have 3 business areas. The biggest one is called packaging paper, which includes market pulp, and that is also the biggest one. It has 39% of the combined net sales of the company last year. We also have consumer board and container board. So as I mentioned, we operate in a global packaging market, and we provide over 1,500 customers globally with products and also services. And we have customer service centers worldwide, as I mentioned. So our biggest market is Europe, but Asia is around 14% of the net sales. And then we have some in Africa, Middle East, South America, and also other markets. So if you look at the benefits of smarter packaging, which is what we want to promote, you can say that there are a lot of advantages of choosing a smarter packaging solutions, and these benefits can be seen and felt all the way through the value chain. And it starts with choosing the correct raw material from the beginning. So that could be choosing the right pulp for your paper, but also goes on to an exciting consumer experience at the end. And smarter packaging is something that we apply to everything that we do, and we communicate the benefits of smarter packaging across 5 key areas, as you can see in the slide. So that is sharper brands that excite and inspire, smoother journeys that preserve the goods, fresher thinking that forms the future. We try to be innovative, for example, greater results that improve the output, and brighter futures that we create together. So if I move more into our market pulps and the mills producing that, as I mentioned, we have 3 different market pulps from 3 different mills. So the first one is BILLERUDKORSNÄS NBSK Gruvan from Gruvan mill in the central or south parts of Sweden. We have BILLERUDKORSNÄS NBSK Karlsborg, which is located close to the Finnish border, so very far up north in Sweden and in the world. We also have BILLERUDKORSNÄS NBSK SKÄRBLACKA from SKÄRBLACKA mill, which is quite close to Gruvan mill. And the capacity of these mills for market pulp was for last year 110,000 tons of flash-dried pulp from Gruvan, 170,000 tons of sheet-dried pulp from Karlsborg, and 65,000 tons of sheet-dried pulp from SKÄRBLACKA. So if we look more on product quality and properties and how that is influenced by the fiber properties, you can say that product properties are mainly determined by the properties of the raw material. I'm sure you all know this, but it's very important to have the right raw material for your end product, and some of it you can change in your process, but it's still very important what you actually start with. So depending on the desired product and paper properties, you should choose a pulp to fit those demands. So this, I mean, the properties that you want in your product is determined by the paper properties, and that goes back to the fiber network properties, which goes back to the pulp fiber properties, and that is depending on the wood fiber properties. So as an example of this, we can take tensile strength. So the tensile strength as a paper property is dependent on the bonding ability of the fiber network. So that is bonded area and bond strength. And the bonded area is connected to conformability of the pulp fiber properties. So that's flexibility and collapsibility of the pulp. And that is also directly connected to the fiber wall thickness. So for example, if you have more early wood fibers in your pulp with a thin fiber wall, that will be beneficial for the tensile strength. So when you refine the pulp, you will get more flexible fibers that will facilitate the formation of fiber-fiber bonds, and you will also increase the amount of fines in the pulp, which will increase the bond strength. And with the refining, you will also get some external fibrillation that will create more surface area. And together with the increased flexibility, this leads to a better bonding between the fibers. And for tear strength, well, tear resistance is a force needed to tear the paper. So that also goes back to the bonding ability of the fiber network. So bonded area and bond strength as for tensile. But it also goes back to directly that you want a little more stiff fiber, and it's also connected to the fiber length. So longer fibers are also good for tear strength. And the more coarser fibers you have, you will also have a higher tear index. So if we zoom into one of our market pulps, we'll start with the BILLERUDKORSNÄS NBSK Gruvan. And that is a flash-dried pulp that is produced from pine and spruce from the central parts of Sweden. And the flash drying means that drying of free fibers that are suspended in hot air. So this drying process is more intense than a sheet drying process of the pulp. And during the flash drying, the fibers usually have full freedom to move during the shrinkage that takes place during the drying process. And this will give you a paper with higher bulk and higher tear strength than fibers dried in a sheet. And due to this obtained stiffness of the fibers in the pulp, it will require more refining to reach the same tensile strength as for a corresponding sheet-dried pulp from the same area. And in a flash dryer, the fibers are dried separated from each other, as I mentioned, in a high-temperature airstream, and compared to sheet drying, where the fibers are restrained while drying. So thanks to this, the fibers are free to rotate during the drying in the flash dryer, and they will also be curlier after the drying, as you can see in the picture, the second picture. But you will have stiff fibers with excellent tear strength and also high bulk. So here you have another picture of this. As I said, flash drying is more intense when it comes to as a drying method, and you will have more stiff fibers. So if you see in the picture here, you will have a higher tear strength of the flash dried pulp compared to a sheet dried pulp. So these are two pulps that are basically from the same area, but the drying methods are different. So even if you have a pulp that has good tear strength before, when you flash dry it, it will actually increase a little bit more. So you will have excellent tear strength from Gruvan, and also excellent bulk, and also very good porosity. So this pulp is suitable for all sorts of end uses, including specialties like filter paper. And as I mentioned before, these market pulps are from 3 of our integrated mills. So the pulp that we dry and sell as market pulp is also used in our own processes, and we have very high demands when it comes to quality on our own paper products. So if we move on to BILLERUDKORSNÄS NBSK Karlsborg, this pulp is quite different from the Gruvan pulp. This pulp has, it's produced from pine and spruce, just like Gruvan pulp, but it's pine and spruce that are harvested very close to the Arctic Circle. And when the trees are growing this far up north, that means that they grow very slowly, because the growing season is very short. And you will have a very high share of early wood fibers compared to pulps that are from the more south parts of Sweden and the world, I guess. But you will have a high share of early wood fibers in this pulp, and they're very slender, but also very thin-walled fibers, and they beat very easily, as you can see in the pictures. And this will give you a high tensile strength at very low energy consumption. And this is also for Karlsborg. This was from a study that was performed by Immensia when they refined the pulps to 50 kilowatt hours per ton. And it's a comparison between Karlsborg and 2 other Scandinavian pulps, a Canadian pulp, one from North America and one from South America. So as you can see, Karlsborg and the Canadian pulp are basically on the same level when it comes to tensile strength. And then you have 2 the Scandinavian pulps that are a bit lower in tensile, but still good and higher than the North American and South American pulps. So this advantage of very high tensile strength from a Karlsborg pulp can be used in 3 ways, and this could also be applied to, for example, SKÄRBLACKA, that I will mention in a bit. But you can have increased tensile strength in the final product since the tensile development is faster and you have a higher tensile strength compared to other pulps. Or you can reduce the refining energy that you use to reach the same tensile strength in the final product as for other pulps. So for example, if you only want to reach a tensile index of 50, you can decrease the refining. And you can also use this in a way to reduce the amount of softwood in the end product and perhaps have more hardwood or more fillers, but still have the same strength. And then I'm going to move on to our third and last market pulp, which is BILLERUDKORSNÄS NBSK SKÄRBLACKA. When it comes to the composition of the pulp, you can say that this one is more similar to gruvan when it comes to how much early wood fibers and late wood fibers you have in it. As you could see before, those mills are more geographically placed on the same level compared to Karlsborg, which is very far up north. But this is also a long fiber pulp, just as the others, that is produced from pine and spruce from the central and southern parts of Sweden. It's based on strong but still flexible fibers, and it doesn't compromise with either strength or printability properties. Since it has more late wood fibers than Karlsborg, it's a little less easily collapsed, but it's still a medium collapsible fiber that will retain high stiffness and also have very good bonding properties. So this pulp will have high tear and high tensile strength, but the tensile won't be as high as for the Karlsborg pulp, and the tear strength won't be as high as for the gruvan pulp, but still very good. And this is also some more information to show the differences in paper properties and how they can be related to the amount of late wood fibers or early wood fibers in the pulp. So in the pictures you can see a comparison with a pulp from the south of Sweden and the north of Sweden. And I think you should remember that even pulp from the south of Sweden is still very far up north in the world. So they will still have a very high tensile strength and also good tear strength, but yeah, tensile will be lower than from the north. So yeah, the amount of early and late wood fibers will affect the character or the characteristics of the pulp. And early wood fibers has a better ability to form bonds since it has larger contact area of the collapsed fibers, as I mentioned before. So this will have a higher tensile strength, as you can see in the bottom picture, which shows the development of tensile during PFI refining. And if you have more late wood fibers, you will have they will be more stiff and not as easily collapsed, so they will have a higher tear strength, as you can also see in the top figure. So this pulp will have a high tensile and a nice tear strength, but not as high tensile as from Karlsborg or as high tear as from gruvan. But this pulp is suitable for many kinds of products, for example, paperboard or tissue, but also different other kinds of kraft papers. As I mentioned, we also use them for our own paper production. And this is another comparison that we have. This was a comparison between a Canadian pulp, Karlsborg, SKÄRBLACKA, one radiata pulp, and one southern pine. And this was a lab study that was performed at our Karlsborg mill in our laboratory there, where we have a PFI lab refiner. So as you can see, compared to the other pulps, BILLERUDKORSNÄS NBSK Karlsborg has a significantly higher tensile index together with the Canadian pulp than the others. But if you compare SKÄRBLACKA NBSK to radiata and southern pine, you can see that it has a higher level than them. So that's what I was talking about before, that you have the internal differences in Sweden, but still a pulp from the south of Sweden will still have very high strength. And southern pine has quite low strength, and the radiata here as well. As you can see, they don't reach the same levels at all, and have to be refined a lot more to reach the same strength level as the others do at, I don't know, 6,500 or even lower revolutions in the PFI. So if we sum it up a little bit about the different market pulps that we have, you can see that the gruvan pulp has a higher share of late wood fibers, than the Carlsberg pulp. So this will have naturally a good tear strength, but since it is flash dried, the tear strength increases even more. So the tear strength is superior, you could say, and the tensile isn't that high. And it also has high bulk and also nice porosity. And the Carlsberg has a very high share of early wood fibers. It's a sheet-dried pulp, and since it has a lot of early wood fibers, it's easily collapsed during refining and will have superior tensile strength. And is also very easily beaten, as I mentioned. And SKÄRBLACKA, when it comes to the compositions of wood fibers, it has, like Gruvan, a higher share of late wood fibers. But since it's sheet-dried, you don't lose tensile strength and you don't gain as much tear. But it has both high tear and tensile strength, and is, I would say, considered as a high-quality pulp. And so my conclusions from this would be that a high-quality pulp will improve the product properties, especially in these cases concerning tensile strength, but also tear strength. And if we focus on SKÄRBLACKA, BILLERUDKORSNÄS NBSK SKÄRBLACKA, it has an advantage in strength compared to radiata and southern pine. So a high-quality pulp and also choosing the right pulp for your product will improve its properties. And generally speaking, Scandinavian pulps are more easy to refine than, for example, radiata pulp, as you saw. And SKÄRBLACKA will have an advantage in strength compared to this pulp and the southern pine. So compared to this, using SKÄRBLACKA can have some benefits for the production economy, so you can save some money. For example, since you have a higher tensile level, you can increase the input of hardwood pulp and decrease the amount of softwood in the furnish, so that will save you some money. Or you can refine the pulp less, so you can save energy and therefore also cost compared to, for example, radiata. And I wouldn't make any promises when it comes to the refining, but I know it depends on the energy prices and the paper process that you use, but yeah, maybe $10 in general figures. And also from a logistics setup, this pulp is quite good because when it comes to the connections to India, we have quite nice logistics solutions, which we also do from Gruvan, but not so much from Carlsberg to India since it's located very far up north. So if you want more information about the company, you can go to our website, which is BILLERUDKORSNÄS.com. And on the second link I have, which you can also find from the website, you can find the data sheets for the market pulps and also our certifications. Or you can contact me on my email address if you come up with questions later. Okay, so thank you. And now I'm done.
Hello. Yeah. Good evening, everybody. My name is Dinesh Ghai. So I'm session now onwards. there was some problem initially regarding the moderation. So now we thank you to Ms. Lois for giving the wonderful presentation. Now we are opening the dais for the question answers. So anybody who has who wants to ask questions can ask the questions through this question window, and I will be speaking the name of the people and question, and then Louis would be answering the question. And so we have already started receiving some questions. So I'll be just stating there is a person called named Mr. Chiranjeev Pathak. He has asked a question that is flash drying applicable to virgin pulp only? So I would request Ms. Louis to kindly answer this. आपने लुइस को दे दिया ये स्पीकिंग
Okay, could you repeat the question, please?
I'm just repeating. I'm repeating the question. Is flash drying applicable to virgin pulp only?
To this pulp? Or I don't quite understand the last part of the question.
What Mr. Chiranjeev Pathak is saying is flash drying is applicable to virgin pulp only. I think he mean to say that whether we can do it.
Okay, I'm not quite sure actually. I can find out, and then if he drops me an email, I can get back to him and find out. But I'm not quite sure. But we only have virgin pulp, so I only know our own process actually.
He has further clarified what to do if we use waste recycling. That is his further. So I think what he mean to say is it possible if somebody is having a waste paper mill, can flash drying be applied? So that is,
yeah, I'm not quite sure.
okay.
Sorry. Are there any other questions?
Any other question by any of the participant? We would love to answer. There is a question from Dr. Sundar Raman. He is asking that thermal and electrical power consumption comparison between flash dried versus sheet pulp.
Can you repeat the question?
What he is asking is, what is the thermal and electrical power consumption comparison between the flash dried pulp versus the sheet pulp?
Okay. Well, the flash drive requires more energy, but I can't say any numbers.
Any other question from any of the participants?
Okay, so if there are no other questions, thank you for listening. And please email me if you have any other questions that you want to contact me about.
So we would like to thank Ms. Louise for the valuable presentation which she has given. So now we would like to invite the second presenter. He is Mr. Anders Nilsson. He belongs to a company called Frontway. Mr. Anders Nilsson graduated with a MSc in Chemical Engineering from Royal Institute of Technology in Stockholm, Sweden, and in 1984. In 1996, he completed his degree in paper technology at the Royal Institute of Technology in Stockholm, and by a thesis and study about simulation. Mr. Nilsson has worked for a number of years in different positions with experience from management, board making, engineering, and IT, IS management. From year 2004, he is managing his own company within simulation software services and products. So he would be talking about something related to the simulation, how simulation can help in optimization of raw materials. So I would request Mr. Nilsson to kindly have a presentation, sir.
Hello. Do you see my screen?
Yeah, Mr. Nilsson, we're looking at your screen. Please go ahead.
Okay.
Thank you.
Yeah, okay. To check, you see this screen and you see this second screen with a flow sheet. Is that correct?
Yeah, we can see that. Thank you.
Okay, good. Shall I start then?
Yeah, please go ahead.
Yeah, okay. Thank you all for the opportunity to make this presentation, and please put up questions and I will try to answer them as I understood afterwards this general presentation. My name is Anders Nilsson and I'm working at the company and heading the company Frontway in Sweden. And this is me. I do have a mixed background. I started up this company in 2004. I've been producing board for a number of years, waste paper mill in different positions. Also been working as process consultant and chemical engineer. I have a chemical engineering background and somewhere I also have a degree in paper technology based on the software we are using today. Do you hear me loud and clear? Okay. I have made a short agenda and it's a Frontway presentation, a couple of slides, and then I've written something fact and non-fact description, and I'm trying to define the problematics regarding raw material on large scale, not only in a mill. Also going to show you a small sample of a model, and then I'm ready for questions. And Frontway as a company, we cover a lot of things including programming, databases, modeling, education, also process engineering, project management and automation. The process engineering part is very much of importance due to the fact that when making a model a lot of process issues comes up. So that is a necessity for us to have the mix. What's unique with Frontway then? Well, we think we are unique in the way that we have a system thinking when it comes to our deliveries. Everything we do when it comes to our deliveries are stored in a database. They are stored there, all the settings and all the results. And we do a lot of simulation models where everything is stored. This is a picture of my garden in Sweden. It is a pear tree. It's full with fruit. And you know, it's a common saying by consultants that they pick the low-hanging fruits. At Frontway, with our technique, we are much more aggressive than that. We pick all the fruits, not only the low-hanging. And this also means at the end that we sometimes do find apples in the pear tree. Not physical, I haven't done that yet, but we do find things that wasn't expected. That is what we would like to say. And by handling everything in via database, it also means that we have a very good opportunity to find settings and combinations that wasn't planned for, so to say. And this has been a success. We build models, and in this case, as I show now, it's a model. Looks like a flow sheet. It is just a start of one stock preparation. It is very simplified in this case, but still probably too much of complexity for the questions regarding the general raw material handling. I will come back to that in a couple of minutes. fact and non-fact description. So now I'm leaving Frontway as a company and goes into what I think the questions that are risen here. And as a general thing, raw material depends on, you have somewhere 1, 2 or several pulp and chemical suppliers into India, either into India or in India, and they have to be counted for in an eventual model showing the results and the changes and how to do in the future. Also, you have to look at all the paper producers you have of today, all paper machines, all mills. Of course, only the major ones, but still they have to be counted for, and their production budget has to be taken into the simulation model. And of course, there are consumers at the end, and the demands, what you are expecting from the consumers. It is by purpose I have written fact and non-fact regarding this part of the presentation, because you really don't know how much the consumers will buy next year and the year after and so on. So there will be some probability in this type of modeling, some sort of statistic evaluation to make a proper result evaluation. To handle those questions, we want, of course, to build a model. And this model is based on inputs. And our suggestion there is probably that 20 mills, at least 20 mills, the major mills in India, are supposed to be part of this model. And we think that those 20 mills, there we have to describe them for different production scenarios on different frequencies and timelines, so to say. And also for the whole India as a country, at least 20 scenarios has to be defined for the future. And I'm not sure here if it is 20 mills or if it is 25 or 30, but 20 might be a good starter. And we think, when we look at this, that 20 mills times 1 day of work, 20 mill scenarios times 1 day of work, and 20 scenarios times 1 day of work. So there is a substantial amount of work in this, but the result is important, and it's difficult to do this without doing any sort of simulation and calculation. Otherwise it will just be guesses. And of course on this we will make scenarios, and in the scenarios we think that the 5 years from now are to be handled at least, and probably with a time length of a month or maybe a week. So each year has to be divided into 52 parts if we are on a weekly basis, and that means that the production budget has to be divided in 52 parts. The reason why we want this to be done on that frequency is that we also want to take into account seasonal effects. From my remembrance from board production, we had seasonal effects regarding Christmas time. We had seasonal effects regarding summer when everybody wanted to buy ice cream. And we always saw a seasonal effect a number of months or weeks in advance. And I guess you have similar things in India. Also, what has to be studied is, of course, logistic demands. If you are going to take raw material from another country, then of course we have to figure out how often, what is a realistic batch, where to store it, and so on. And that has to be into this model. And then as an output, and the output, I've written it very simple here, 1 day of workshop. And of course that is with a lot of preparation. has to be involving cooperation with Inventia, I guess, and also with CII to make this workshop worthwhile. In total, we think there is about 4 months of work involved in this, at least from our side, to make a valuable output. But when you have the output, then you will have a quite proper model for decision support, and that can be reused every year, and you can from time to time update the model and make it better and better. And the experience I have is that the advantage of the model is that it will put everybody together, everybody will talk the same language and get a general understanding and the same understanding about the problematics. And that is a general thing. It doesn't always falls back, it doesn't only falls back to the raw material handling. It's always that when it comes to the simulation. What we will do is to build simplified models, like model for board, paper, news, and tissue. And those machines will of course then be fed with fiber of different types, water, chemicals, fillers. And the board here, or paper, news, and of course then 5 years later there will be changes. Maybe there are more board machines. In that case it will give a higher need of fiber input. This has to be defined. We at this moment don't know that much about the India pulp and paper industry. We've got some information from the Swedish Business Sweden, and based on that we have done some short modeling, but to do something realistic here we need to have more. And of course somewhere in the modeling there will be storages or buffers in between, and they have to be handled, especially when we talk about the logistics situation. To give you a brief example, here is a model, and what we can do with our models is that we can make them look like this one, and this is simplified. Here I see fiber, virgin fiber, bagasse, recycled fiber, water, chemicals coming into the process. And they are then splitted for use in production lines like board, corrugated, disposable, other wood products. You see here a very much easy or very high level picture of a paper machine with the head box, the wire section, press, dryer, and pulp. This is built as an hierarchical block, and this hierarchical block, I can double click on this one, and then you will see that we have very much simplified this model. So actually the whole paper machine is replaced by, in our case, a screw press, where we just define that we have an outcome of 90% dryness. And we don't need more than that to do the simulation when it comes to this. What's most important is the mixer over here, where we have entered that we have a split of different fiber types like 50, 40, and 10%. Those values can be handled via the scenario handler and the database. And there we have an opportunity to make very much different evaluations here, depending on what's happening over time. But I also want to mention, if someone wants to describe his or her machine much more in depth, then of course we can put in a flow sheet like this into the model. That's doable. We can go very much in detail, where we have the dryer, we have the press section, we have the whole wire section, very much in detail described. But that just to show you that we have the opportunity and the possibility here to dig down into details in the model somewhere, and other part can be very much presented as a summary result or input. So we have an opportunity to play here with very exact figures in one part here, other parts where you have more of non-exact input. There we can also enter statistical inputs based on randomized figures. But we want to avoid that because that makes the evaluation more difficult to do. And our experience here is that the less randomized values we have, the better it is for the explanation of the model. So now we have shown you this. We have given you a very brief explanation about the company, our uniqueness with the database, and of course now we are interested in if there are any questions or there are any discussions in this topic. Okay, thank you a lot for your attention. Any questions?
Okay, ladies and gentlemen, if there is any questions, please enter them into the questions window. Yeah, we have a question. We have a question from Dr. Sundara Raman. Energy should also be included as input. What is the prediction? Sorry, there's a question from Mr. Chiranjit Pathak. What is the prediction for virgin pulp market in India in the next 5 years? Over to you, Mr. Anders.
Yeah. We don't actually know the prediction for this. We have heard some figures regarding double production figures, but this is something where we need input from the different mills here. And when we put the figures together in the model, I'm going to show you here on the screen. In here, when we put the figures for all board producing, and if we then add 5% or 10% or 15% per year, then we will see the impact, the total impact on the fiber, water, chemicals and fillers demands. And that is difficult to foresee by doing it by hand or just by looking at it, because here we will into those different mixers depending on what raw material you need, and also depending on the different mixing when it comes to different qualities you are making. And see this summary as a total that will come out when we have made a simulation of, let's say, 20 or 25 mills at the same time. Coming back to the question regarding energy, of course we will put in energy calculations in this. Yes, we will do, but the first primary thing to do to get the model up and running properly, that is to get the material balance. But still, of course, the chemical or the energy part will be added at the end. But if I have a question there, of course, are we talking about thermal energy or are we talking about power energy? Because this has to be splitted, and the need of thermal energy is of course one part, where probably steam is the generated thermal based on something that could be raw material also, or part of the raw material stream. And some of those mills of the 20, they will be more complicated since they will be integrated. Was that answer enough on the two questions?
Yeah, and now we have another question from Dr. Sundar Raman. Recent modeling or simulation done on energy savings achieved may kindly be elicited.
Okay, the energy savings can be handled and can be shown in this, yes. More questions, please? Or did I answer the question correctly or enough?
Yeah, and another question from Mr. Chiranjit Pathak. He says energy should be an input.
Energy should be an input when it comes to, let's say, drying, but you also need energy as an input for the machines. It has to be. But then we have to, well, of course, you can go into detail, very much in detail, so I think we will have some key figures of energy usage for machinery here.
Okay, now we have a question from Mr. Pathak once again. It says blending of waste paper and virgin pulp should be another input. What will be your suggestion?
You will have long fiber, short fiber, and of course, if you are discussing an addition, let's say, the virgin pulp here could be domestic or from abroad. You could, of course, have bagasse, you could have recycled paper, but the usage of different type of fiber here is, of course, different when you make tissue compared to news, compared to printing paper, compared to board. And for each type of production here, there will be different mixtures or different recipes, and those recipes must be based on the actual mill recipes, but of course still on a very overview level, but it's necessary to have them split depending on the type of quality. And I don't know when I made this presentation if there are additional pulp types that you want to have into this model. If you have, then we can enter them. That's no problem.
Okay, now we have a question from Dr. Sundaraman again. He's asking quality of final product to be related.
Okay, quality is difficult to simulate in the same model here. We have done it, but that is a third or a fourth step. To make this type of simulation, we assume that the given recipes will also make the qualities wanted. But of course, if you have a board quality of, let's say, 300 GSM, then we enter the recipes for 300 GSM. If you have another board quality for 180 GSM, then we enter the recipe for that. And based on those recipes, we just assume that the produced qualities are correct. We can't do anything else at this moment. If we should, let's say, go into very much depth regarding quality, then we are not talking about 4, 5, 6 months of work. Then we are talking about 4, 5, 6 years at least to do, and that's not will not provide a better answer.
Okay, now we have a question from Mr. Pathak saying that raw material cost should be another input. EHT, will you suggest?
We can use costing as an input also, that's no problem. That can be done in two different ways. Either that we, now I'm going to switch into the model, and let's see now. Still not ready. Okay, thanks. What I was going to say is that in the process flow here, we can handle up to 100 components. And in the process flow, there could be different fiber types, of course, water, steam. We can also handle some quality variables as well as costing. So we can either handle it directly into the model, or, which actually seems to work very, very much well, that is to make the material and energy balance in the model and then send the output to Excel for further calculations when it comes to the costing. But we can handle the both cases here, and we have to figure out during, let's say, start-up of this type of project which way that is most convenient and gives the best and quickest answers. But both can be handled, but definitely costing can be into the system.
Okay, thank you, Anders. Now I am requesting my colleague Mr. Dinesh Ghai to take over, please. So Dinesh, please go ahead.
Yeah, am I audible? Yeah. So thank you, Mr. Nelson, for all the good presentation. And in between, I actually got disconnected, so I could not participate in the question answer session. But I could see it has gone really well, and people have really given. Mr. Nelson has given the inputs, whatever was needed. So with this, we are now closing the webinar for the first day. We would be restarting the webinar sharp at 4 o'clock tomorrow, and we would be starting the webinar sharp at 4 o'clock tomorrow. So I would like to welcome you all again at 4 o'clock tomorrow here. Thank you, sir. Thanks a lot for joining us.